Welcome back to The Explainer. Today, we're doing something a little different. We are going full-on chemistry detectives, and we're investigating the hidden science tucked away right inside your very own home. You might think of chemistry as this super complex thing confined to some sterile laboratory, but actually, you're interacting with these amazing chemical compounds every single day. Let's uncover this invisible world right around us.
So how well do you actually know your kitchen? I mean, it seems like a pretty simple question, right? You know exactly where the plates are, you know where to find your favorite snacks, but what about the actual chemical identities of the things sitting quietly on your countertops or hiding out in your pantry? The truth is, everyday items have these secret chemical identities hiding right in plain sight. They have distinct characteristics that dictate exactly how they taste, how they feel, and how they react with the world around them. And today, we're going to expose those identities. Section 1, the acid and base divide.
When we talk about chemical solutions, our two main suspects, if you will, are acids and bases. Now, before we get into any complex testing, our own senses actually give us our very first clues. Acids carry a huge sensory clue. They taste sour. You know that sharp, puckering sensation when you bite into something? Yeah, that's just your tongue literally detecting acidity. Bases, on the other hand, have a totally different profile. They are distinctly bitter and have this very specific, slippery, almost soapy feel to them. So these are basically the physical fingerprints of our chemical suspects. Okay, let's dive into this. It's one thing to talk about sour tastes and soapy textures in the abstract, right? But we need hard evidence. Let's examine the suspects in your pantry. Specific, everyday examples of these chemical profiles that you probably have sitting in your house at this very moment. When we break down what's in your pantry, it's actually pretty fascinating to see the split. Over on the acid side, you've got that lemon you squeeze into your water, everyday vinegar, curd, which actually contains lactic acid, and tamarind, which is packed with tartaric acid. Then look at your bases. You've got your everyday hand soap, lime water, and of course, good old baking soda. You are quite literally eating, cleaning, and cooking with these incredibly distinct chemical compounds on a daily basis. But what if we can't taste or touch a substance to find out what it is? This is a major roadblock for us as chemistry detectives. Relying on taste or touch is great for leaven or some baking soda, but as a hard and fast rule, tasting or touching unknown chemicals is a terrible and honestly super dangerous idea. We absolutely need a way to detect and identify these suspects safely, visually, and completely unmistakably. Which brings us to Section 2, Meet the Chemical Detectives. So if we can't taste or touch to figure out a substance, what do? Well, we bring in an indicator. By definition, an indicator is basically anything that changes color in the presence of an acid or a base. Especially when we are trying to figure out how these chemical indicators actually detect acids, this is the key piece of the puzzle. The indicator physically reacts with the acid, altering its own molecular structure. That structural shift literally changes how the substance absorbs light, which changes its color to our eyes. So the crucial point here is that it acts as this brilliant, purely visual alarm system for chemistry. Let's look at a classic example, litmus. Litmus acts as the ultimate chemical referee here. Say we want to detect those sour suspects we talked about earlier, the acids. We simply take a strip of blue litmus paper. The very second those acid molecules interact with the paper, boom, it immediately turns red. That red color is your definitive, undeniable visual verdict, acid detected. And conversely, if you expose red litmus to a base, it turns blue. It's just such an elegant, instantaneous way to identify our suspects based entirely on a structural, color-changing reaction. Let's move on and see how this builds in Section 3, Nature's Hidden Color Changers. So we've talked about litmus, which is obviously a fantastic tool, but it begs the question, are indicators only made in labs? I mean, when we think of chemical testing, we almost always picture factories and highly controlled manufacturing, right? Well, the true origin of these indicators is actually a pretty surprising and honestly beautiful twist in our investigation. The answer is absolutely not. Nature actually provides its very own chemical indicators. Take turmeric, for example. That bright yellow spice probably sitting in your spice rack right now. It acts as a completely natural indicator. Same goes for red cabbage juice, which will dramatically change colors depending on exactly what you mix it with. And perhaps most beautifully, hydrangea flower petals possess these exact same indicating properties. The earth itself actually grows the exact tools we need to detect this chemical divide. As we wrap up today's explainer, I want to leave you with this final thought. We are constantly surrounded by this incredible, interactive world of unseen science. The sour acids, the bitter bases, and those beautiful natural color-changing indicators just waiting to reveal them. So the next time you look at a hydrangea blooming in a garden or squeeze a sour lemon over your dinner, ask yourself, what invisible chemistry is hiding in plain sight? Keep observing, keep asking questions, and hey, thank you so much for joining me to explore this fascinating topic.